Dear students, in today's lecture, you'll know about the GIS Geographic Information System applications in agriculture and forestry. Upcoming next, we will discuss about the fishery and wildlife. During today's lecture, we are going to discuss about the agriculture and forestry with GIS applications. Let's start. Today's lecture, our discussion will be about the GIS applications in agriculture. And up next, we will know about forestry, current trends of GIS and remote sensing based applications perspective. So start about the GIS applications in agriculture first. What are the major applications of GIS in agriculture field? As we know, the agriculture play a very key role, a backbone role in any country economy. Either it's developed or undeveloped. Means to say, if it's developing country like Pakistan, you see, or you can exemplify our country that our Pakistan itself in a stage of development. So even the underdeveloped part, but the poor countries like in Africa countries, the agriculture has a very dominant role in economies of these countries, either they are developed or undeveloped. Because with agriculture, the food securities also remain intact, and also the other kind of uh, production or another kind of import and export also regulated or related with the agriculture sector of any country. Like any country, the people and also all the rely on the food. So for that purpose, for link purpose, we know the food importance cannot be ignored. For any country that has population, so they need food for their survival. That was they regulate the economies. And they also import sometimes the food from other countries as well. So for any country, as we see in Pakistan, uh, we know come to know that Pakistan have more than 70% of our economy is based on agriculture. It's other thing that agriculture might not be that much developing or developed, but to certain extent the exact figures might not be that, but the major role of that uh, agriculture is in the economy of Pakistan and also the countries. What actually in agriculture sector, farmer or other regional or large scale, either local or up to national scale agencies and other food organizations or agencies or authorities need to know. They need to know they have to know about the quantity and quality knowledge and information about the country agriculture sector. What can be possible eat, what can be the better production, what's the production actually, what are the realities, what are the facts and figures that are coming with the share of the economy from the agriculture sector. So these all information the agriculture sector should have in their knowledge bank, and for the estimate of all the products that can be the food products and agriculture related products, cereals, etc., so their prices and worldwide trending, what are their current trend, what's going on in the international market and also in the local market, what are the perspective and what are the prospective of these prices and their quality and quantity on the basis of their regional or national knowledge, and then in comparison or in relation to the international trade. So these all information need to be known by the agriculture sector to better manage the economy in perspective of agriculture of any country. In this regard, how the GIS will help us, how the GIS will help any country that either it's on the regional or local scale or it's on the national level, how the GIS will help to understand the agriculture perspective, what can be the better applications of GIS in that agriculture. And so then that aspect, uh, farmers, either if they are in the regional, local, either they are on the large scale like in the national level or international level, as I have discussed, so they need to know about the quantity as well as quality, not only quantity. In a quality perspective, they need to know about the health of crops, potential yield that can come from the quantity sector, as I have mentioned that quantity and quality both matters. But here we will discuss stepwise in the next section what can be the both quality based applications or assessment of the agriculture on the base of GIS along with also remote sensing tools. So in that perspective, the health of crop is also an important part of agriculture application. Potential yield, that can be the quantity, what is the production, and soil condition, that also comes under the assessment or the quality of agriculture perspective. GIS in agriculture actually basically helps the farmers to achieve or increase production and also to reduce costs by enabling better management of the land resources. Here I have given the graphical example of general vegetation index or greenhouse vegetation index. Here you can see the color based hyperbar that is shown, the variation based bar or color bar of that quality, that is the greenhouse vegetation index. Where there is a dense vegetation, you can see the figures are given from the 0 to 100 in figure, that's in the, either you can see in the percent or shown a standard digit for that, which is being based on 0 to 100 figure digit count. So the bare soil you will see in that 0 to 2, that's the greenness vegetation index. Where there is a dense vegetation, it can be seen in the very greenness or bluish sector. From here you can see that if you take the GIS perspective of application along with the remote sensing, all this light data, you can see it can be applied in regional, local or international, even I mean national level. If you go for the crops management or the yield, you will firstly know about the greenish vegetation, how much area you have a barren or there is barren area with you, or either the vegetation health or index is going to be good, or either they are in the potential to be good for production, or either they are barren, or if you have cropped this crop, if you have ploughed the field but they are shown good barren, or they are showing not a good much index in aspect of greenness vegetation, then obviously their yield will be not that much good. So potential yield will become on the basis of that quality. So that was a little basis or intro about the application of agriculture, and actually we are going to know what can be the major and the important applications in agriculture and the current trend that's going in the GIS along with the remote sensing or satellite data applications, applying the simulations and the tools in GIS based applications perspective. So firstly we will go towards the major agriculture applications of GIS and along with remote sensing, because if we see that from satellite data we can better assess the far away or very diverse area of any region or any area of any country or even the continent level or the global level. So firstly we will start with the qualitative aspect of the GIS along with remote sensing in the applications in agriculture. Mapping of soil characteristics. What possibly can be the soil characteristics? What are these areas soil? What's actually the area we are going to cultivate? We are focusing the agriculture application where we want to be go for any agriculture kind of activity. What are the soil activity? Either they are clay, loamy, etc., etc. This can be better known in the hard sciences subject, that what can be the soil properties. Either it's useless for other crop, or it is used for that crops, and they are yielded for that crop. So in that perspective, the soil characteristic can be easily mapped in that GIS along with remote sensing data. What can be the better soil management practices? Because after knowing the qualitative aspect of the soil, their characteristics, and you will have to manage the soil on the basis of their better practices for the agriculture sector for any kind of crop yield. And after that, if you go for the standard based farming, that compliance monitoring, you know the health of the crop, you know, sorry, the quality of that crop, of the area soil, quality of the soil, and then you better manage the area for any kind of crop cultivation of crop. So for that, you should know about the compliance with standard based farming. Because if you see, like we can take the example, like in any area, if you see the Pakistan, sometime you will know, like they are mentioned on that walls or other places, especially if you go in Punjab from the agricultural livestock section, that use that kind of crop, or cereal, or even you say the wheat, that kind of a wheat hybrid, these kind of wheat farm, these wheat can be used in that year or in that season. So they are literally and already giving the information about the better management of that kind of cereal crop for that area or for that season. And they even are giving the actually the standard farming practices. So that's can be easily done in that GS, because along that we know about betterly the soil management and also the soil practices of any area. One can be crop type classification. On that basis, we can better understand, like here I have mentioned that example can be assessed, can be related with this crop type classification, also the monitoring and also assessment as well as estimation. What crop here, if you see, or give an example from a reference source, that is the GIS remote sensing based application, that that imagery has been taken from any area considered. So on that 45 meter 45 meter points grid basis, like 45 megapixel base grid was taken, and that simple points, if you see, if we are only we are taking for the example, but these color bar are chloroplate made, that's the chloropate or thematic map of that area crop. What are the high cultivated areas here are being shown as a more green. Then the medium cultivation areas are also being shown. That's the standard farming practices are the management based practices. And then the crop type classification can be easily done. Low cultivation area are being are pivot irrigation. From that, if we see that their crop type classification can be assessed if that area is suitable for any kind of like wheat or rice, etc. for maize. So if we go for the standard based compliance monitoring practices, standard farm practices, we will know about the classification of that crops of that area is yielding, and that is better, that has a better yield for that kind of crop. So crop condition assessment can also be assessed on that basis. So what is the crop condition assessment? What is actually the crop condition? Like I have mentioned in the earlier slide, the crop health can be betterly understood by dietary remote sensing GIS based application. What are the yield in that area, what can be the crop condition, what is the great condition, what are the updated crop condition, either they are giving a question of good greenness, or either they are giving a little bit greenness, a little comparatively little greenness to the other area. So that can then betterly go towards the crop yield as well. This crop, obviously after the condition assessment, they can give you the estimation figures and facts as well. So that was the basis about the magic agriculture creation of GIS and remote sensing in agriculture. So up next we will go towards the applications of GIS remote sensing and especially GIS tools in forestry. What are the forestry based application? As we know, the forests are very valuable and also the basis source for any country because they also provide food, shelter to the wildlife and like flora and fauna. That place habitat for the flora and fauna, especially fauna, and they provide timber and other all the fuel that's on the base of timber and daily supplies to the local and also regional and country basis. Uh, Here I will have to mention that forest are renewable source. It also means that someone economist has mentioned that for any country, we are supposed to be a 30% crop. Forests supposed to be in the country area for a better economic perspective, for better economy and for better regional management and for better biodiversity. However, if we go for Pakistan, we can understand that there will be the problem of the forest cover. Up next, if we see in the forest importance, obviously as environmentalist as economical, you know that it balances the CO2 balance, carbon dioxide. They are sink for carbon dioxide if they supplied in say half, because from the, we better know that from plants they release these they release the oxygen to us, and alternatively and automatically in the process for photosynthesis they cover the CO2 and they absorb CO2, so they are sink for that. So in that aspect, there are also a link between atmosphere, like giving the oxygen to and absorbing CO2 between the geosphere we are residing here, and they are also giving support to geosphere and also hydrosphere, how maintaining the water cycle as well. We have not mentioned the biosphere, but biosphere respectively is giving us the major chunk of oxygen to the living beings, human and animals. If we see in the global perspective, tropical rainforest that is residing to the Tropic of Cancer, Tropic of Capricorn, like the equatorial areas or the subtropical areas, the rainforests are immense because in that areas the rain, due to the temperature and pressure gradients, remain most of the year, and the immense diversity of species can be found in that tropical areas because also they adapt to the changing environmental conditions. Like if you see for the polar areas comparatively, the polar areas remain mostly Antarctic or Arctic regions like North or South Pole. So there the forests may be a little bit covered, but they remain in the intact in the very extreme temperature, rather the very low temperature. And if we go for the tropical areas, that's near to the equator or near to the Tropic of Capricorn or Tropic of Cancer, so their diversity will be immense if we go for the global perspective, global view of that forest cover. However, after all that importance, after all these basis of their importance in any country, in any region, and any global level, the main issues of forest management remain here. What can be the major issues for their forests? Because the forests can be depleted due to the natural causes or human activities. Natural causes in the near past, you can remember the happening and a very natural disaster of that Amazon forest, which we see that more than half percent of CO2 sink is there. Like that is a big case for immense species diversity of forest there, Amazon forest, and they are also giving a very good balance of temperature and oxygen regulation to the heart. And also due to human activities, as I mentioned, that daily supplies and fuel are based on that, so that can be linked and related to the daily supplies and fuel base. So the uh, unregulated and not very green, not a green way to go for the forest cover usage and fire depletion. That's the issues of forest management. For that purpose, monitoring of health and growth for effective commercial acquisition and conservation is necessary. So to better give the yield and better give the daily supplies of fuel and other needs of the global or nature area or any kind of that usage of the forest. So we will discuss now in that part what can be the major implications of for GIS and processing in forestry as well. What are actually the current trends of GIS remote sensing, especially using by the forest agencies, many agencies that are local, regional, and international agencies and companies, either they are in the private sector or the national government sector and public sector. What are their trends? So they mostly focus on the cover type, shoreline watershed mapping, monitoring. Monitoring there come the protection, cutting and vegetation, like afforestation, forest fire farming, and in that aspect and that basis, the major implication will include firstly reconnaissance based mapping or exploration based mapping. In exploration based mapping, there come the forest cover updating. To update the forest cover, how much cover the forest has in that area or that region, even the country on global level. What are their depletion? What cover of forest has been depleted so far, and that can give the update of that forest cover type, or what kind of vegetation are there, and also the agricultural based forest mapping. Here if we see how if given the lighter base, that is light detection and ranging remote sensing database application of GIS tool simulation. Here if we see, that's the height of that trees. Here we are generating the color plot or color bar, color base variation bar. You see that the trees come at the 0 to 15 meter or up to the 80 meter plus level area. So that 80 meter plus forest will give you, if you monitor it updated base curve monitoring and mapping, if you will give this, it will give you the assessment how much forests are being depleted, how much forests are being cut, or how much forests are being giving the better growth in that area and on this spatial available in that area and that time. Also the agricultural forestry based mapping can be done in that way. Up next, and the second part will be the commercial forestry. Commercial base, like for the timber supplies or other kind of forestry, collecting harvest farm information like reforestation, afforestation, inventory information for timber supply. Up next, the broad forest type. Vegetation density can be covered by the GIS based simulations, and also the biomass measurement, like what are their net primary productivity and gross primary productivity of that species or that forest cover in that area, and that clear cut mapping, how much they are being cutted, how much they are being harvested, and regeneration assessment, like how much our afforestation has been done. In that aspect, we can also take the example of a green tsunami which was being introduced in Pakistan government in the recent 2 or 3 years. So in that aspect, if you see what amount of regeneration has been done, that can be better can be done in the GIS and field. Burn delineation, as I have discussed, Amazon recent past Amazon disaster, Amazon fire, forest fire disaster, to assess the supply and susceptibility of forest to that fire, and again the area that has been clear cutted are being burned, and again what can be our susceptibility for the upcoming any kind of such happenings, natural fire or disaster. Infrastructure-based mapping and operations support can also be done. What are the infrastructure for that area forest can be done? What kind of steps can be done for the management and operation of the reforestation or this forest support? Forest inventory detailed study, thematic study of forest can also be done on the basis of the all other perspective to give the forest spatial temporal base perspective. analysis. And also the biomass estimation, I have discussed before, biomass estimation, biomass management. So that's a net parameter, net gross parameter productivity of the forest can be done. Species inventory, how, what kind and what where the species are found and what can be their better yield and better um, productivity or their growth in that certain area and certain region, certain time. So last but not least, environmental or greenhouse monitoring based assessment. Here also I have shown the global forest watch. I will discuss. Firstly, we will not know what can be the JSA and processing based applications. So in that environmental awareness monitoring based aspect, monitoring quality, health, diversity of the earth forest can be easily assessed and it can be easily updated and monitored in that GIS remote sensing perspective. And that part, and I in all the part here I have given the example of the online that is given the land reference source. You can search for your own study or for your own reference or even for your own ideas. Here, the forest change has been shown for land cover, land use, climate, even the biodiversity, and other explored the areas anywhere else in the world. You can go in here for the Pakistan, you can zoom in, and you can apply the area, and also here the data has been given. So that's the monitoring or updating of that data. This site, that is the global forest watch, it is observing from the last 2 decades. So the data, if even maybe for the one or other region we are maybe not also updated data for, if you go to a certain region their data is updated. But in that part, in that aspect, you can also apply the GIS remote sensing yourself for that kind of applications. And more than that, like for deforestation, rainforest either and mangrove colonies that are even in Pakistan, some countries are there. And rainforests, equatorial or tropical areas can be assessed. Species inventory, as I was almost discussing the recognized information with MIPI, their identification can also be done. Watershed protection or riparian strips. What are riparian strips? That are located, that strips are that forest types that are located on the banks of a river or stream. So that can also be better conserved along with the coastal protection. There's a mangrove forest. Even if you go here for the Karachi, the coastal areas, mangrove colonies are there. But if you yourself being a student or if you being a researcher, you can also betterly conserve or go for monitor the updated information, data and information knowledge about that forest to conserve them or either go for their protection. Like if you go for the wildlife by just along with the forest data. That was a little more about the GIS and processing applications in agriculture forestry. Up next, we will go for the forest GIS 300 processing application in fishery and wildlife.